All right, so today Sean and I are going to be talking about air pressure, heat, and volume. So first we just defined all three of the subjects. So air pressure is the force exerted onto a surface purely by the weight of the air. And heat obviously is the quality of being hot. And volume is the amount of space that a substance or object occupies or that is enclosed within a container, especially when great. All right, so for the first example, we are going to use two regular bike tires. So the first tire is going to have a skinnier area or volume, so it's less of a volume. And the second tire is going to have a lot thicker tire, and it's going to have a lot greater volume. And so if we drew the same amount of air particles inside the tires, 2, 3, 4, 5, 6, 7, 8. If we drew 8 air particles in each tire, 1, 2, 3, 4, 5, 6, 7, then the pressure inside of the tire, the skinnier tire, is going to be greater than it is inside the thicker tire, because there's more room for the particles to move around in the thicker tire. So if there's not as much room, there's obviously going to be more pressure, which leads us to the point that so if we put pressure, if we drew it on a graph, pressure and volume, pressure, as the pressure is as the volume gets greater, then the pressure decreases, like an example in this one, like this connects to that one, because there's less pressure, so the pressure is going down because the volume is larger. All right, for our second example, we're going to be talking about how pressure and heat are related. So same as before, we'll use two tires, except this time they'll be the same width and cover the same volume, and they'll still have we'll just say 8 particles in each, so they'll have equal amount of particles, except the difference in this one is that we'll say this tire was in the sun all day, so it was getting soaked up in the heat, whereas this one was just in someone's garage or something. So this tire was in the sun all day, so that means that what heat does to particles is it heats them up and gives them a bunch of energy, which makes them shoot around everywhere, because particles, these particles are still moving, but these just have a lot more energy because of the heat, so they're shooting around the tire everywhere, which as a result makes the tire have more pressure than one that usually wouldn't. So if we put it on a graph, pressure and heat. So as there's more heat, like in this tire, which was soaked up in the sun all day, it causes the particles to move around, which in result makes the tire have more pressure. So heat and pressure go hand in hand.
Okay, so the heat and volume have a direct relationship, because as we talked about earlier, as the heat increases, the pressure also increases. And as the pressure increases, it makes the atoms want to expand because they're moving around, pushing against the boundaries, making it larger. Therefore, as a result, if the heat rises, the volume will also rise. Like in a graph, this will be so the volume, also the graph would look like this, because as the volume rises, the heat would also rise, just like pressure and heat. And